Lisa, and thanks everybody for attending. I'd like to start by acknowledging my co-authors. I'm a PhD student at the University of Vermont, advised by Ellen Marsden and Jason Stockwell. Lars Rudstrom at Cornell had a major hand in this survey, and Bernie Pienka and Dave Gibson at Vermont Fish and Wildlife collected a ton of the survey data, both in the past and in the past couple of years. So I'm going to provide an update today on an assessment of pelagic forage fish in Lake Champlain that captures the time during and then after alewife invasion. So small pelagic fish are important because they form a trophic link between zooplankton and piscivorous fish, including lake trout and salmon. Small pelagic fish or forage fish tend to have quick life cycles with boom and bust population dynamics, and have been noted to limit the production of salmon and lake trout in other lakes. But what's interesting is that forage fish can compete with each other and have interactions with other forage fish since they're feeding on the same food base, which is that zooplankton and larval fish resource. Alewife and rainbow smelt are really interesting because across North America we have this gradient of invasion. So depending on the ecological setting, these fish can either be native or non-native. So I'm working in Lake Champlain, where we're somewhere in the middle. You can see that both alewife and rainbow smelt are native along the Atlantic coast and invasive in the Great Lakes. Lake Champlain is pretty unique because we have a population of native rainbow smelt where alewife invaded relatively recently. So there's a very unique opportunity to study the invasion of alewife into this relatively undisturbed system. Lake Champlain is even more interesting because we have several distinct basins that almost act as unique lakes within this larger lake system. So if we start by just looking at basin volume and maximum depth, our largest basin is the main lake, which forms the majority of the western arm of the lake. We also have the inland sea, which is a medium-sized basin to the northeast, and Mallett's Bay, which is a very small basin, pretty much to the east. And all of these are separated by causeways and natural geological variation. They also differ in productivity, or the food source for our forage fish. So the main lake is relatively low to medium in productivity, the inland sea is very high, and Mallett's Bay is rather low. If we go up a trophic level from our forage fish of interest, the predators vary throughout the lake as well. So there are many piscivorous fish in the main lake, and then some medium occurrences, especially of Atlantic salmon in the inland sea and Mallett's Bay. Okay, to add another level of complexity, we have mysis, which are large freshwater zooplankton that are only found in the main lake. And mysis are important because they form a very lipid-rich food source that sustains smelt and alewife in the main lake, but not in the inland sea and Mallett's Bay, which are too warm and shallow to support mysis. And so previous research has set up this hypothesis that alewife will have different impacts on rainbow smelt in the different basins of the lake. And this is largely due to limitations in food supply and limitations in oxythermal habitat, since rainbow smelt require relatively cold, deeper water. And so there's this idea that in the main lake, after alewife invaded, there's enough habitat and food to support the coexistence of rainbow smelt and alewife. In the inland sea, we predict some sort of a medium relationship because there's a medium size of the basin and lower predation by piscivores. And then in Mallett's Bay, we predict the strongest impact because it's the smallest basin by volume and the lowest in productivity. So there's our hypotheses here. So I'm going to step you through some of the major biological events in Lake Champlain, and then how managers have responded, especially in terms of forage fish survey efforts. So Lake Champlain has been stocked at a relatively high rate. Atlantic salmon stocking and lake trout stocking started really sometime around the 1960s. A midwater trawl survey began in the late 1980s to assess smelt as a forage base for continued stocking of predators, which was paired with sea lamprey control efforts. So again, the question is there a forage base of smelt? to support these predators that are being stocked and then likely surviving at higher rates after sea life prey control. So then the forage fish survey was expanded, and in 2005 to 2015 there was a structured hydroacoustic survey which is using scientific sonar to estimate biomass of fish, using methods that were borrowed from the Great Lakes to try to get more accurate biomass estimates to what is really in the lake. At the same time, we were having some biological invasions, which I show along the top. So we got zebra mussels in the lake in the early 1990s. Alewife invaded in 2005, which really co-occurred with the start of this hydroacoustic survey. And then recently we have spiny and fishhook water flea, which showed up in sometime around 2014 and 2015. And all of these invaders had impacts on rainbow smelt by altering their food source, zooplankton and larval fish, and then providing the source of competition in the case of alewife. After alewife invaded, floating gill nets were added to the state's survey efforts to try to capture alewife that were near the surface. In 2015, forage fish survey efforts switched over to a bottom trawl survey to focus on juvenile lake trout, which had just started to show wild recruitment in Lake Champlain. And this was a really exciting success story because there was such strong recruitment that lake trout stocking stopped in the past couple of years. But recent observations of declines in salmonid condition, so in other words, seeing skinny lake trout and salmon, have led to increased concerns about the forage base. You can also see that we have some different gear types that were used that don't always overlap in timeline, and so concerns were increasing about the predator-prey ratios in Lake Champlain. So in the past couple of years, we went back and repeated the historic midwater trawl, hydroacoustic, and floating gillnet survey to get an index of forage fish that was directly comparable to the past. And again, this also is useful because it provides a comparison to the bottom trawl survey to inform ongoing efforts to refine our survey efforts and effectively manage Lake Champlain. So what I want to talk about here is the trends that we saw in smelt and alewife populations, both in the historic survey up until 2015 and in our modern repeat of the historic survey in 2024 and 2025. And so we'll look at this through the lens of complementary sampling gears, which each have their own distinct biases, and then across the ecologically and physically distinct basins in the lake. All right, so let's walk through the survey gears here. You can see Lake Champlain on the left, and then on the right I have a little conceptual diagram of the lake where you can see the water surface down to the lake bottom. And our first gear type, which ran for the longest period of time, is the stepped oblique midwater trawl, where a net was stepped from 35 meters to 10 meters below the surface at night when the rainbow smelt and alewife are up, suspended off the bottom, feeding in the water column. And so this occurred at 5 stations throughout the lake and was really effective at capturing yearling and older, or spawning age, rainbow smelt. Because it overlapped with their habitat really effectively, the survey was designed for smelt. We also have yearling and older alewife that aren't fully captured in the survey because they tend to occur in that shallower, warmer water near the lake surface. The step trawl survey can also capture young of year fish, so we do see young of year smelt and alewife that occur in somewhere right around the thermocline in the middle depths. So the trawl doesn't provide a perfect picture, but if there are a lot of young of year fish, you'll see them in the trawl data. We also have hydroacoustics. So this is a down-looking, it's essentially a scientific fish finder, which is run off of a ship, sailing in transects that zigzagged pretty much over the entire lake. And so with acoustics, we're sending down pings of sound and listening for the reflections of sound, which are proportional to the biomass of fish in the water column. But you can see on the plot, there's a limitation here. There are acoustic dead zones near the very surface and near the lake bottom. So we can't actually measure the fish in the top 3 meters of the water column. This is where the floating gill nets come in. So using the floating gill nets, which extend from 0 to 6 meters below the water surface, we can see into that acoustic dead zone. And so all of these nets and acoustic gears provide complementary opportunities to get our hands on fish versus opportunities to cover a lot of space. And so what we saw was that the STEP trawl survey found smelt declines in shallow basins after alewife invasion, again, which is likely a result of oxythermal habitat limitation or competition over food. And we saw that those trends continued. So here are our main lake sites where you can see catch per unit effort along the y-axis, and there you've got time. The top row shows yearling and older fish, and the bottom row shows young of year fish. And what I want you to take away from this is that catches of smelt were relatively low, but not much lower than what's been observed historically. At the same time, catches of alewife were equal or maybe higher in some sites than what was observed. But it looks like the trend is holding pretty steady between the historic and the current survey. It's a little bit different if we move to the Inland Sea and Mallett's Bay, the two shallower basins, where we can see that catches of smelt have continued to decline. So in the Inland Sea, we still caught some fish, but the pattern seems to have flipped, where historically we were just catching a few alewife. Recently, we're catching many. Historically, we kind of saw a slow decline in smelt, and then going back recently, there were very few. This is even more extreme in Mallett's Bay, where there are extremely few rainbow smelt captured, both in the yearling and older age class and in the young of year. So that's concerning to smelt recruitment. We're not seeing a lot of young of year fish. On the other hand, we are seeing a lot of alewife. And then just quickly stepping through the floating gillnet data, we saw major increases in catch per unit effort in our 4-hour net sets throughout the main lake. I'm not showing you the data on the Inland Sea and Mallett's Bay because we had some gear issues, but what we can see is that especially in the north and south main lake, catches of alewife were really high compared to the historic survey. Now I'll step you through the hydroacoustic survey data, where I used temperature profiles to divide the water column into an epi, meta, and hypolimnion, and then assign that to species. So we can assume that in the epilimnion, most of our catch or observations are yearling and older alewife. In the metalimnion, we have a mix of young of year fish. And then in the hypolimnion, we are mostly seeing yearling and older rainbow smelt. And so here I'm plotting backscatter as an acoustic index of biomass. If we start in the main lake, looking at the epilimnion, we see an alewife index that's somewhat within the realm of variation that was observed in 2005 and 2015. In the central main lake, it's a little bit higher than the long-term average. And then we can contrast that, if we look into the hypolimnion again, like the smelt numbers were low, but they're within the large amount of variation that we saw in the historic survey. This lines up really well with what we're seeing in the stepped midwater trawl data. So moving to our two shallower basins, the Inland Sea and Mallett's Bay, we can see that in the Inland Sea, the acoustic index of alewife was quite a bit higher than the historic survey. So it seems like alewife biomass is increasing. In the hypolimnion of the Inland Sea, we can still see that there are some smelt. Again, this lines up really well with the stepped oblique trawl survey. In Mallett's Bay, the acoustic index of alewife was not huge, and so some of that could be due to alewife that occur in the acoustic blind zone in the upper 3 meters of the water column, because we saw really high catches of alewife in floating gillnets that aren't reflected in this acoustic index of alewife. Again, in Mallett's Bay, the hypolimnion is almost empty, which really matches up well with our catch of something on the scale of like dozens instead of thousands of smelt. So to sum this all up, in our recent sampling compared to 2005 to 2015, what we saw were trends that really support the hypothesized impacts of alewife on smelt between the basins. So again, yearling and older smelt in the main lake were equal or lower than historic, and they were much lower than historic levels in the Inland Sea and Mallett's Bay. On the other hand, alewife seemed to be increasing in the lake, especially in the Inland Sea. Young of year fish, which serve as an index of recruitment, were a pretty even mix of smelt and alewife in the main lake, supporting coexistence. But again, in the inland sea in Mallett's Bay, we found very few young of year smelt. So what does this all mean? It looks like there's an increasing proportion of alewife in Lake Champlain compared to historic status, which is pretty concerning because we have quagga mussels on the horizon, likely to invade the lake fairly shortly. And quagga mussels have impacts because they're very strong filterers that will likely decrease the food available to forage fish by decreasing pelagic production. So these quagga mussels divert some of that zooplankton energy, which may impact forage fish by reducing populations of alewife. So ongoing efforts in the lake are to determine the relationships between our forage fish indices from this survey, and indices of piscivore condition and abundance, and then continue to develop robust forage fish survey methods that will capture what's happening in the lake now, and then also what's happening through potential future invasions. So hey, thank you for your time, and thank you for attending. I'm happy to take questions if there's any time.